Hello everybody, my name is Alberto and I am a game developer. This is the third video of a series of video tutorials in code design using the Unity engine. In the last video, we saw the implementation of an example system. In this system, we were able to collect example behaviors from the scene through the enable and disable callbacks from Unity. We would just add these examples to the last index in the array and we would increase this index. In the case of disabling these behaviors, we would swap the index where the disabled example is with the last active one, and we would decrease the last index. And finally, we would use this system to perform any update. In this video, I'm going to focus on the rendering of these examples in the scene, and for that we're going to create a new system which is going to be called Example Rendering System. But before diving to our rendering system, let's take a look to the traditional way of rendering things in the scene, which is through the components like the MeshRenderer. In order to be able to compare between the different rendering techniques, we are going to make use of the stats panel and also of the frame debugger over here. I've created an example prefab over here. This just contains the example behavior, and we are going to add our mesh filter and our mesh renderer. Over here, we are going to add a capsule and a test material. We are going to keep the cast shadows on, receive shadows on, and we are going to disable other options over here. If we go back to the code, to our example system, I've added some lines of code to instantiate a grid of these examples in which we're going to have 100 rows and 100 columns. Over here, I'm feeding this system with this example SO. This scriptable object is very simple. It has a template of the example behavior, which is going to be the prefab we've just seen, and this mesh renderer data that we will see later and we will use for the rendering in our rendering system. Let's go back to the editor. Let's take a look to our material. I'm going to disable the flag enable GPU instancing. When I click on play over here, we're going to see all our capsules render over here, and we see that they have nothing saved by batching. And if I go to the frame debugger and I enable the frame debugger, we can see that we have 17,000 draw calls over here, and most of them, as you can see, is the opaque geometry, which is our mesh. We are drawing the mesh with lots of different draw calls. Let me disable this and play again, and we can see the FPS are very low. We are over 40 FPS, and the CPU main thread is with 33 milliseconds, while the rendering thread is also quite high. We have now the bottleneck is on the CPU side, as you can see over here. Let's see what happened when we enable the GPU instancing. In this case, we are expecting to gain a bit on FPS, but actually we are not gaining too much. Probably we're gaining 5 FPS by enabling the GPU instancing. If we check in the frame debugger, here we can actually see that the draw calls have dropped much to a much lower number, and we can see that actually we are drawing using the instance draw mesh, which means that we are drawing most of these meshes in one single draw call in principle. That's what Unity is in principle doing, but we still have quite a low FPS over here. Let's then take a look to our rendering system. For that, what I'm going to do first of all is to get rid of these two components. We don't need them. We are going to perform the rendering by ourselves. If we go back to the code, to the example system, you can see that I have an array of matrices over here. This is what we are going to use to render these example behaviors. And when we are creating them over here, I'm passing the position to the matrices array to have the initial position. And by now we are not moving them, so I'm actually not updating it in the frame update. But otherwise I could update here the transforms with the position of these examples. But for now, we're going to keep it in this way. If we now go back to our rendering system, we are going to see that this system is very simple. We have, again, a reference to the example. So, because here we have the rendering data. So I'm actually making a copy of this data structure, and we have now the data available over here. We're going to create also a material property block because this is then used in case we want to modify per instance some properties like colors and other different possibilities. In enable and disable, we are going to just add this late update that I actually called exactly as the time in which is performed in the late update. And here we are going to draw the mesh with an instance draw call. We are doing this in the late update because normally you perform all the updates in the frame update, which would be the updates that you perform to this example behavior. So we want to draw after everything has happened. And here it's very simple. I try to mimic exactly what we have with the mesh rendering. We have also the shadow casting on, and I believe it's the receive shadows also enabled. And here you can see that we are passing a mesh, a submesh index, a material. We are getting the transforms from the example system, and we are getting the last index, which is telling us when which one is the last instance we have to or how many the number of instances we have to draw on the scene, the material property block, and that's it. And in every frame we are just sending this to the graphics pipeline, and we are just basically drawing this on the scene. Here this structure is very simple. As you can see, we have the possibility to set this from the editor, and here we have just the mesh, the submesh index, and the material. Let's just take a look what happened when we start and play the editor. Well, interestingly, the FPS now went up to almost 100 FPS. We see that the times are much lower, the render thread is much lower. We have 3 milliseconds and 9 milliseconds on the CPU side. We have here all our examples, and you can see there is no mesh renderer, but we still can see everything because we are drawing it through the graphics API from the Unity engine. If I enable the frame debugger, now this is quite interesting. We can see that actually we have much less draw calls over here, and it's again, of course, draw mesh instance. I would recommend you to really take a look to all these values over here and try to understand as much as possible. You can also use RenderDoc. It's a very interesting tool to have a much deeper understanding of what's going on your screen, what is rendering and in which order. And RenderDoc can also be integrated in the Unity editor. So you could take a snapshot of what's happening in there and see the rendering process. The last thing I wanted to show you is what happens if we actually get rid of all these mono behaviors of all these game objects. Are they actually causing an overheat here? Are they causing these 9 milliseconds to be happening over here? Can we increase even more the performance by getting rid of them? Because in the end, we don't need them. They're just here, but this example behavior is doing nothing. And with this, I want to make you understand that sometimes these mono behaviors, these game objects are not necessary. You could use them as a way of feeding your code, your system with data, no? From the editor, because the editor is your friendly tool to deal with your game and your scene, but you don't need them most of the time, so you could just collect the data and get rid of them, not destroy them. So let's see what we can do with this. In our case, it's going to be much more simple. What I can do is to get rid of this part of the code over here. I can then move down the transforms because we still need the transforms over here. We need to know where to draw our capsules. And I'm going to place this over here. So this is going to make sure that the last index is increasing and that we are filling our transforms with the right position. over here in the frame update, to make it a bit more realistic, I made the dummy method, which is exactly what is the frame update doing, because it does nothing. And at least we are performing this method call over here. So we are trying to mimic exactly the same, but now we do not have these mono behaviors. We are not instantiating these behaviors and creating these game objects. In the example rendering system, everything is the same. Nothing changed over here. Let me save and let's try what happened now. If I click over here, we hope to see everything drawn on the screen. Yeah, over here we have everything. And as you can see, there is no much change over here. So actually having the game objects or not on the scene now is not doing any change. If I come here, this is exactly the same, and that is expected because in the rendering we are not changing anything. We are only changing on the number of game objects that are in the scene. The main reason I wanted to show you the difference between having game objects or not is because in some cases it is very relevant, and in our case we have almost empty game objects, and then it is normal that there is no overheat because of them. But I would recommend you to take a look to the profiler and start checking what happens when you have game objects with different kind of components, and you will see a big difference in the total memory in use, and that actually can be crucial in your game depending on what type of game you're doing and the size of your game, the number of assets and objects that you have on your scene. And finally, I wanted to just mention something. We didn't see something here, which is actually very interesting. This is draw mesh instance. This is for instance draw calls. And this example was a very simple example and which doesn't seem to have much more use. But let's consider the possibility of combining meshes. Let's say that you are working on scenes that are heavily loaded on environment which is mostly static. Of course, you can use the static batching from the Unity engine. You can enable this on the game object, and in principle, the Unity will make for you this process of collecting whatever is the same in terms of meshes, materials, and it can be rendered in one single call, and it will try to combine all these meshes to perform this process, which is much more performant than drawing each one separately. However, we saw already for the instance draw mesh that there is a mismatch when you do it or when Unity does it. And it is not that we are doing it better, that's not the case. It is most of the times it's just because Unity has to take into account many more other possibilities and scenarios, right? And then when you are working on your specific problem or issue, most of the times you can find a better solution if you do it yourself. So I'm not going to write example here, but you can see in the Unity documentation, mesh combine meshes, these methods over here allow you to collect several meshes that they can come, for example, from a mesh filter or just from your own meshes in the editor in your assets, and you can just collect all them in these combined instances and combine them in one single mesh. You can only do this again if the material and properties are the same. So you will actually have to be sure that whatever object you are trying to combine, they share these properties, and then they can be combined and draw in one single draw call. And before ending the video, I actually wanted to show you these rendering techniques in place. This is a clear example of this type of rendering. This is the game I'm working currently now. And in this game, I'm drawing everything using the graphics API of Unity. If you look on the left side, this game object has nothing to do with all the entities and units that you see in the scene. They are all rendered using the graphics API. Also, these visual effects that appear over here are rendered using this API. And we can see on the statistics panel that the FPS is quite high. The rendering thread is just 1 milliseconds right now, and the CPU is also kept low. With this, I just wanted to show you that it is possible to build up and render your whole game using this API, and then you actually have full control on what you're rendering on the scene. And I'm actually very happy with using this approach because it's very simple for me to add new effects and start working with different techniques with shaders, and it's all under your control. So thanks a lot for watching, and yeah, I hope to see you next time. For the next one, I think I want to talk about data, how to deal with the systems group architecture and having your data in the editor, and how can you actually work with that in a let's say user-friendly way.